Welcome to my presentation on Jenkins machine learning plugin. I'm so excited to present my work I have done for this GSoC. And also I would like to thank my mentors, Bruno, Ionis, Maki, and Shivai for great feedbacks and suggestions. And also thankful for our Jenkins org admins who makes this event successful. So let me introduce myself. I'm a GSoC student for machine learning plugin Jenkins for 2020, and I'm doing my major in computer science and engineering. So before we move into this technical aspects of the machine learning plugin, I would like to explain a little bit about what is machine learning operations. So if you take any machine learning operations, continuous analyze and continuous training is a very essential part to improve this quality of these machine learning products. So as you see in the diagram, data scientists will analyze the data sets, and then they build their model and train their model, and finally they will hand it to the DevOps engineers, and they will test and deploy, and they will do the rest of production works using their application code. So let me explain about how it's possible, how they are achieving using this using the plugins of the Jenkins in the ML operations. So if you take one machine learning operations, there must be multiple steps like training, pre-processing, and validation. So there's a lots of intermediate steps are there. So for the clustering tools, you can make it possible to use one of those Docker plugin or a Kubernetes plugin. So there's lots of clustering tools available in Jenkins. And also, if you want to manage your source codes, you have a Git plugin. And if you have a large file size, like large data sets, large models, you have to manage that also. So Jenkins has some advanced plugin like S3 publishers. You can easily publish your models or data sets to this AWS S3. And if you want to if you want to submit your analysis, and if you want to publish your reports in somewhere, you have some analytic plugins also available in the Jenkins. And Jupyter Notebook is widely used by data scientists to analysis and training models. So in addition, we are giving this Jenkins machine learning plugin to leverage all the plugins to make the ML operations successful. So let me explain what are the features we have implemented during this GSoC period. So the first one is very data science community friendly configuration about the kernels. So if you want to check what are the kernels you have installed in your system, you can just go to your terminal or your command prompt. You can just type Jupyter kernel spec list. So it will display all the kernels you have installed in your system. So I will explain a little more when we're doing the demo how to do that. And let me pass to the next slide. And we have this wrapper included in our plugin that will helpful for converting your Python or converting your notebooks to the Python or JSON. Or if you want to rename this notebook, you can do with this wrapper included in this plugin. And this is our main feature of this plugin. So we have to give the ML task name, which will be helpful if you have any artifacts like images, HTML generated by the notebook. It will be saved under the name, like for example, it will be saved under the training folder. So it's the purpose of this giving machine learning task name. And the next one is you have to select one of kernels you have configured in the kernel configuration. So for example, I have selected for this screenshot as a JavaScript, and you can give this code, or if you can write the code directly, or you can give the notebook's name or a script name in the file parser. So finally, we have a features like if you have any images or HTML generated in the Jupyter Notebook, it will be saved under workspace. So there's a action in the left panel. You can see image and HTML. So you can click it and you can view what are the images generated in the Jupyter Notebook. So we will see very detailed in the demo. So yeah, I will go to the demo directly. So before we go in demo, I have a GitHub repository which contains some CSV data sets and some Python enabled notebooks and R enabled notebooks. So for this demo, I'm going to run this Python enabled notebook and R notebook. So you can see here, this is a R notebook. You can see they have used R codes here. So there's a pure R code. So they have using a ggplot to make the graphs in this notebook. And the other one is it's using the Python code directly. You can see that. So for graphing, they are using the matplotlib library. So yeah. So first we're going to create we're going to configure our kernels here. So you can go to configure systems, and then you can find kernel configurations here. So you can just add new kernel here, and I will tell you how to find what are the kernels have been installed in your system. You can just type Jupyter kernel spec list. So these are the list of kernels that I have installed in my system. So I just choosing Python 3 and R. So I just configuring Python 3. So the language, I just type Python. For what is so the launching time mode, I just setting as a default 10 seconds. So it takes time to connect. The launching time mode is how long it would take to connect to this kernel from the Jenkins, and the max resource is how many lines can be sent back to this Jenkins from the kernel. So you can here have a test connection button. You can test your kernels from here. So I'm adding also a new kernel for IR. Like we have seen that there's IR kernel. So for this R, so I just setting this 100 and I'm testing this kernel here. So yeah, we are good to go with this kernel configurations. So we're gonna create a simple freestyle job for this demo. Yeah, it's a final. Okay, just selecting freestyle. Yeah, so for that, I'm going to check out my repository here. So I just getting my repository. Here, I just and for building these notebooks, this is the essential part of this plugin. You have to give if you want if it's training, you can just add training, and you can select either one of these. So we are going to run here Python enabled notebook. So I just selecting my Python notebook. Okay, the name. So I just giving the name of the Python notebook because it is already exists. It will be checked out from the GitHub to Jenkins workspace. So you can directly use the name of this notebook. And also I will add another builder for IR. So I just and I'm selecting this IR. So for the file, I just giving the name of our notebooks. Yeah. So yeah, we are all good to go with this job configuration. So we just one step left. I will run that. So here you can see this is a Git checkout console log, and you can see there's HTML is added to the training folder, and there's a lots of images have been added to this training. So if you want to check whether it is added to this workspace, you can just check here. And the generated images and the other plots are here. So you can even try to view your HTMLs generated in the notebook. Yeah. So if you want to publish these results to somewhere, you can use the HTML publisher plugin, or you can leverage the other plugins to make the result viewable in somewhere. Yeah. So yeah, so that's the demo part. I will shifting to this main presentation. So this is the link to our GitHub repository, and if you feel any issues about our plugin, I forgot to say that we have released our plugin version 1.0.1. You can directly download from the main update center. So when you are using, if you feel any issues, if you feel any errors, you can report it here. We are happy to help you. And if you have any questions, you can ask directly in our Jupyter channel dedicated for GSoC machine learning project. And this is my demo repository. You can use it if you want to try that demo I have shown before. And I will show you what are the kernels available in the Jupyter kernel project. So you can see if you want to run a Julia code, if you want to run Haskell, if you want to run Ruby, you can just install these kernels in your system, and you have to configure that in your Jenkins, and you can directly use that. So that's the best part of this machine learning plugin. And yeah. So for future improvements, we are trying to implement. We will try to implement the issue like at this moment we have to give this the kernel features, and we have to type it manually. So if we implemented this automatically, adding a label to the agent based on the kernel features, we don't have to type that. We can have a drop down list or something like that, or we can leverage that thing to easily configure our kernels. So that's the thing we are concerning right now. And we were also struggling when we testing this plugin, because everything is in the back. There's lots of Python work, so we also expecting to write more tests in the plugin. And in ML operations, we have to concern about the performance of the plugin, because performance is one of the essential thing in the ML operations. So that's the thing we are concerning right now. And yeah, so thank you once again. Thank you for joining with this presentation, and thanks for my mentors, and thanks for Martin to hosting this presentation. And yeah.
Thank you, Loghi. Do we have comments or questions?
Yeah, sure.
Not that I see so far in the chat. So if anyone has any questions, please ask using Zoom Q&A, and we will ask presenters. And meanwhile, while we wait for questions, if mentors or other panelists would like to give some comments, please do so.
Oleg, if I may comment, this is Yanis Muchachos. I was one of the mentors. You know, we have work now twice, last year and this year, and finally we succeeded. And I think it has progressed quite well. Loghi was a very excellent student, and he was able to bring together a lot of technologies that are required for this particular plugin, which is a little bit challenging, but you know, he rose to the challenge, and I think we have a really nice version 1.0 now that a lot of us really, you know, as users now are excited and waiting to use. So I am really thankful to the GSoC program for making this a reality, and I think we're moving into a great area with new Jenkins applications.
Thanks for your feedback.
Yeah. And I mean, like, it's fine. I'll also just like to, speak a couple of words for Loghi, because, it has been really amazing, working with Loghi on this project, because, first of all, working on it from scratch, and Loghi, from the start, he was always, up to the task and always completing all of the tasks before, the deadlines. And that was, probably the most, the best, work that we saw was, always maintaining that consistency, and also coming up with great solutions for solving all the different kind of issues that we run into with the plugin. And there were also instances where we did take in some suggestions from external people as well, and those were also implemented. And probably like one of the best features at the end was to add multi-language support, not just Python but also the other kind of data science languages that people will be using. A lot of them are using R, Julia. So having that integration as well within this plugin makes it so accessible for all different kind of data science related workflows, right? So it was like a treat to be working with Loghi and all the other mentors as well, both Ionis, Marky in the starting, and Bruno. So I mean, in all, Loghi made it completely successful, and I'm like so proud of whatever work he has done for the plugin.
Yeah. Thank you, Shivai. Thanks for your compliments. Thank you.
I would just like to echo what everybody else has said, and also just say, Loghi, you're an amazing person. You not only put together a very futuristic plugin here, but you did it during a pandemic, which is that's a pretty big deal. So thank you, and thank you to all the other mentors.
Great. Thanks for all your great comments, everybody. And let's move on